Hey everyone, this is a Module 15 review study guide. All the theorems that we've learned are at the very top for you guys to refer to. The first couple of questions, what theorem are you going to use to solve the angle measures in problems 1 to 3? You can use the acronym. So the acronyms are like VAT for vertical angles, IAT, inscribed angles, in parentheses. Are any of the angles central, inscribed, or neither? So for this first one, let's answer this question first. Are any of the angles central, inscribed, or neither? So central angles have to go through the center of the circle. Clearly this isn't going through the center. Inscribed means it's on the circle. So as you guys can see, this point here isn't on the circle. So for this particular case, it's going to be neither. Because it's neither, we need to use a certain theorem, intersecting chords angle measure theorem specifically. So let me write down that acronym, ICAMT. And that theorem states that the angle, this angle UTV, the measure of angle UTV is going to be equal to half of the measure of UV arc plus the measure of KW arc. So this is the piece that's my question mark. Question mark is this portion here. And then I have my UV arc, this piece, and my KW arc. So now we're just going to solve now. The measure of UTV is question mark, and that's going to equal 1/2 of 130 plus 50. So when we add those two pieces together, we end up taking 1/2 of 180 degrees. So then question mark is 1/2 of 180, which is 90 degrees. For that one. For number 2, are any of the angles central, inscribed, or neither? In this case as well, it's not going through the center and it's also not inscribed. So this is also neither. And we're going to use the same theorem. Intersecting chords angle measure theorem. We're going to use the same formula. Let me be consistent here. So this is going to be the piece that I'm trying to find. And the order of your arcs doesn't really matter since we're adding. So one of the arcs is the piece that we're actually solving for. So the measure of angle SQR equals 1/2 of the measure of SR plus the measure of TC arc. So now, this is my blue piece, 100, and I'm going to put 145 here, and then TC, and I'm actually going to solve for this yellow portion. So I have 100 equals 1/2 of 145 plus my question mark. In order to get question mark by itself, I need to multiply by 2 to both sides. And what this does is it helps us isolate question mark by itself. So 2 times 100 gives us 200. And this equals 145 plus question mark. So now if I'm trying to get question mark by itself, I subtract 145 from both sides. So this gives me 55 equals question mark. Okay, so for number 3, are any of the sides a diameter of the circle? So we're looking at this picture here. So let me answer if it's central, inscribed, or neither. So this angle here is not a central angle because it's not going through the center. These chords land us on the circle, so this becomes an inscribed angle. So this piece is inscribed. This is an inscribed angle, so we are going to want to use inscribed angle theorem on this one. Are any of the sides a diameter of the circle? Remember, diameter is going through the center of the circle. From my picture here, there's this point, dB is going through the center, so we would say dB is the diameter. And how do you know this? I'll have you guys answer that. How do you know that this is the diameter? Part I, was there an angle that would imply any of the sides are the diameter? So, particularly, when we have a diameter, that means that the arc is 180 degrees, since it's a half of a circle, semicircle. And using the inscribed angle theorem, it says that the measure of the angle, so measure of angle DCB, is going to equal half of the arc of DB. So my arc here is 180. So the measure of angle DCB is going to be half of 180, which is 90 degrees. So the measure of angle DCB is 90. Okay, so for the next page, next two problems 4 to 11. State what theorem you would use to solve for the angle measures. You can use acronym. So these theorems from that first page are the ones you're going to want to refer back to, so you can go through your notes. Also state whether the angles are central, inscribed, or supplementary. I'm also going to put neither. They might be neither, so I'll add that on there. So for number 4, let's answer this first question. Is it a central angle, inscribed, or neither? So because it's touching the circle at all 3 points, we know this is an inscribed. This is clearly an inscribed angle. And inscribed angle theorem says that the measure of angle BAC is going to equal half of the measure of the arc from B to C. So, to find question mark here, I know what my angle is. It's 35. 35 equals half of the measure of BC. This is the piece that I'm looking for. In order to get this part by itself, I'm going to multiply 2 to both sides. So my fraction ends up going away. And 2 times 35 is 70, and that's going to be the measure of BC, the arc. For number 5, again, this is also an inscribed angle. Inscribed. And inscribed angle theorem, IAT. So let me put that on this one as well. IAT, inscribed angles theorem. Inscribed angles theorem says that the measure of the angle, LMK, equals half of the arc from L to K. So here we're actually given the arc. So I know what this piece is. So the measure of angle LMK is going to equal half of 168 degrees. So the measure of angle LMK, half of 168 is 84 degrees. Number 6. Here I'm looking for this arc from X to Y, but let's see what we're given in the picture. I have a triangle here, and I'm only given one angle. And this angle here is an inscribed angle. So I'm going to want to use inscribed angle theorem that says the measure of angle ZXY equals half of the arc from Z to Y. So I know that angle is 55. That's 1/2 of the measure of zy, the arc. So if I multiply both sides by 2, that gives me the arc measure. 55 times 2 is 110. So the measure of zy is 110. But that's not what we're trying to find. We're trying to find this arc here. What we just found was the measure of this piece. But now that I know that zy is 110, I know that zx is 130, the whole circle is 360. If we take 360 and subtract these two, 130 plus 110, that's going to give us the measure of the arc from y to x, that arc. So we end up with 360, take away 240, and this gives us 120 degrees. Now yx is 120. Number 7 here. Here we're trying to find this arc. And from what I have here, I have an inscribed quadrilateral. So I have inscribed angles. So I'm going to want to use IAT, but I also have a quadrilateral. So on the front page, inscribed quadrilateral theorem is something I'm going to want to look at. IQT as well. IQT. So this piece is 83. Inscribed angle theorem says the measure of angle BAJ is going to be equal to half of the arc from B to J. BCJ. So here we end up with 83 equals 1/2 of the measure of BCJ. If we multiply that by 2, we get 83 times 2. So 3 times 2 is 6. 8 times 2 is 16. 166 equals the measure of BC, which is this upper piece here. This whole thing is 166. But remember, we're trying to find the arc of BA. So the whole circle is 360. If I take away these two arcs, I'm left with what I want to find. So 360, take away 166 plus 56. $360 minus 222. 8. $138 degrees. Number 8 asks us to find the measure of FGH, this arc, FG to H. And from the picture, I can see that I have an inscribed quadrilateral. So I want to use the inscribed quadrilateral theorem. And this theorem says that the opposite angles, so I'm going to pick out the angles that I have information for. These opposite angles are supplementary. So the measure of angle G plus the measure of angle Q is going to equal 180 degrees. This is the geometry piece from the theorem. Now we're back in Algebra 1, and we're going to solve for x by plugging in what we have for each piece. We get 18x plus 18 equals 180. Subtract 18 from both sides, we end up with 162 equals 18x. Divide by 18, and x equals 9. So now that I know what this piece is, this isn't my answer. Remember, I'm trying to find the measure of FGH. And FGH is this arc right here, FGH. And this arc is creates the inscribed angle Q. So I'm going to put inscribed angle theorem here, because that's going to be the next one we use. Inscribed angle theorem says that if we double this angle, FQH, it's going to give me that arc. So let's find what angle Q is first. the measure of angle Q is going to be 11 times 9 plus 11. This 9 came from what we just solved for. So we get 99 plus 11, which is 110 degrees. So this angle here is 110 degrees. Now to find this arc, let me move to this side here. The measure of angle FQH is going to equal half of the arc FGH. So I know that piece is 110. So half of the measure of FGH. If we multiply both sides by 2, we get the measure of FGH. That arc is 2 times 110, which is 220. Number 9. This is just like the first question in the front. We want to use, this one has a long name, intersecting chords angle measure theorem. Intersecting chords angle measure theorem. Here's my acronym. And this theorem says that this angle here, this question mark, is going to be my 2 arcs. Average, so we're going to add those 2 pieces and cut it in half. So the measure of angle SRT equals 1/2 of the arc of ST plus the arc of BU. So the measure of angle SRT is going to equal 1/2 times the quantity 107 plus 95. If we add those 2 pieces together, 107 plus 95 is 202. If you cut 202 in half, the measure of SRT gives us 101 degrees. So number 10 on the back side, here we have an inscribed quadrilateral, so I want to use inscribed quadrilateral theorem here that says that opposite angles are supplementary. Let me zoom in a little more. So this means angle Y plus angle W will equal 180, and angle X plus angle Z equals 180. So since I have enough information for the green angles, we're going to start off with those. So the measure of angle Y plus the measure of angle W equals 180. So we have 8x plus 21 plus 7x minus 6 equals 180. Combine your like terms, we end up with 15x. 21 minus 6 is 15 equals 180. Subtract 15 from both sides. 180 minus 15 is 165. And if we divide this by 15, x equals 11. So now that we know x is 11, I can find the measure of angle Y and W by plugging in our value here. So let's start off with Y. 8 times 11 plus 21 is going to equal 109 degrees. And angle W is 7 times 11 minus 6. So 77 minus 6 is 71 degrees. You can double check. Adding these 2 angles together should give you 180. And if it doesn't, then we made a mistake somewhere. This X is going to help us find Z as well. So we have 10 times 11 minus 1. 10 times 11 minus 1 gives us 109. So since this angle is 109, I know that its opposite angle has to give me 180. So I'll write this out for you guys anyway. 180 take away 109 equals 71 for angle X. So this angle X is also going to be 71 degrees. I'll leave 11 for you guys to practice. And let's move on to 12. 12 to 17 says, state the theorem that you're going to use to solve for the line segments. So in this picture here, I have two tangent lines. The theorem that we're going to want to use secant tangent product theorem, secant tangent exterior angle measure theorem. Either one's fine, I guess. Tangent secant exterior angle theorem. Tangent secant exterior angle measure theorem. Okay, so basically the tangent lines are equal to each other. They're intersecting at this point. And let's just find what x is. So we're going to set these guys equal to each other. Subtract 17x from both sides. 2x minus 1 equals 3. Add 1 to both sides. 2x equals 4. Divide by 2. X equals 2. And I'll leave 13 for you guys to practice. Okay, so this next one, 14, find RT. RT is a chord, and it looks like we have all the pieces for all the chords. We're going to want to use chord-chord product theorem on this one. Chord-chord product theorem, or I guess CCPT. Chord-chord product theorem. Chord-chord product theorem says that the measure of RA times the measure of AT times AT is going to equal the measure of SA times the measure of AQ. Okay, and I like to write what each part is, so I know RA is 12, AT is 7x, SA is 6, and AQ is 14. And then plug in accordingly. 12 times 7x equals 6 times 14. So 12 times 7x gives us 84x, and that is going to equal 6 times 14, which is 84. So if we divide both sides by 84, x equals 1. This means that AT is 7 times 1, which means all of our t is going to be 12 plus 7, which is 19. And I'm going to leave 15 for you guys to practice. Down here, 15. Secant line is a line that touches the circle twice. So we have secant product theorem here to find the measure of x. Secant product theorem. And secant product theorem is a little bit different than chord product. It says take the whole measure and multiply it by the exterior measure. So we're going to have 17 plus 10 for the whole green piece multiplied by 10. And that's going to equal the other side, which is not 9x, but 9 plus x, or x plus 9 times the exterior, which is 9. So we end up with 27 times 10, 270. That's going to equal 9x plus 81. Subtract 81 from both sides. And we get 189 equals 9x. And we divide by 9. X equals 21. So since x equals 21, I can tell you what my yellow segment is. My yellow segment is x plus 21. I'm sorry, x plus 9. X equals 21. So I have 21 plus 9 is 30 for my yellow segment, and my green segment is 27. 17 plus 10 equals 27. Yellow, green, since I don't have letters to describe them by. And I'll have you guys do 16 for practice. On the back side, 17, let's do this one. 17 is asking for the measure of this arc right here. So this looks like one of our exterior angle measures. So it looks like it's going to be secant, since these guys are touching the circle twice. So what this says is secant exterior measure theorem. Secant exterior angle measure theorem. This guy states that the angle, so we're going to call this angle AGE, is equal to half of my red piece, which is the arc of AE, taking away this inner arc, which is 45, the measure of HF. So I know this piece is 50 for my picture. That it's going to equal half of question mark minus 45. If we multiply both sides by 2, we'll get rid of the fraction. So we'll get 100 equals question mark minus 45. So if we add 45 to both sides, we'll get question mark equals 145 degrees. And I'll leave all the other ones left for practice. This one's a good one to practice since it's the most recent.